Afternoon, ladies and gentlemen. Welcome to the fourth session of MPMA Plastech Month 2025 with the theme of Flexible Packaging Innovations for Performance, Sustainability, and Circularity. My name is Francis, and I will be your MC this afternoon. Let me run quickly through the etiquette for the webinar today. You would notice that we have muted and turned off video for all participants. This is to ensure no disruptions to the speakers throughout the webinar. Participants may ask or post questions related to the presentations in the Q&A box during the webinar. I repeat, participants may ask or post questions related to the presentations in the Q&A box during the webinar. The speakers will only answer questions that are clearly written and based on the presentations. Kindly refrain from marketing your goods or services in the Q&A box. Kindly also refrain from posting comments or remarks to questions posted in the Q&A box. The Q&A box is only for queries related to the presentations. The organizer reserves the right to remove participants who run afoul of the webinar etiquette. The MPMA Plastech Month 2025 is brought to you by MPMA with the generous support of sponsors from or related to the Malaysian plastics industry. Please allow me to thank all our sponsors. Our gold sponsor, Petronas Chemicals Group Berhad. Our silver sponsors, Alliance Bank Malaysia Berhad, Arbek Sendirian Berhad, Control Union Malaysia Sendirian Berhad, Clarion Singapore Private Limited, Data Color Asia Pacific Hong Kong Limited, Angel, Exxon Mobil Chemical Malaysia Sendirian Berhad, Fang Sheng Machinery Company Limited, Hai-Ten Hua Yuan Singapore Private Limited, Kohli Printing and Converting Machines Private Limited, Maki, Miro, Monitor ERP System Southeast Asia, Tedrick Machinery Company Limited. Our other sponsors include Janushka Malaysia Sendirian Berhad, Kampaf Jägenberg Group, Reifenhauser Asia Pacific Company Limited. Thank you to all our sponsors for making the MPMA Plastech Month 2025 a reality. We would also like to thank Malaysia External Trade Development Corporation Matrade and the Ministry of Housing and Local Government KPKT for participating and speaking at MPMA Plastech Month 2025. Without further ado, let me introduce our moderator for this afternoon session, Mr. Augustine Chua. Mr. Augustine Chua has a Bachelor of Science in Chemistry from University of Science Malaysia and has been involved in the plastics industry since 1985. In the 39 years, he has obtained a wide experience in plastics, covering blown film, cast film, printing machine, bag making machine, blow molding machine, injection machines, compounding machines, and plastic resins. Mr. Augustine Chua, the microphone is yours.
Good afternoon, ladies and gentlemen. Welcome to the fourth sessions of the MPMA's Plastech Month 2025.
Oh, Mr. Augustine, can you put on your video, please? Okay, nice.
Good afternoon, ladies and gentlemen, and welcome to the fourth session of the MPMA Plastech Month 2025. Today, we are focusing on the what's new and what will shape flexible packaging for the coming years. We have 5 speakers this afternoon, so we have a lot to cover. Without further ado, it gives me the great pleasure to introduce our first speaker for this afternoon sessions. Our first speaker is Mr. Joe Anthony, and he is a Senior Key Account Manager for General Scar. With an education background in printing technology and over 18 years of industry experience, including experience with leading design agencies, Mr. Joe Anthony brings extensive expertise in repro graphics, graver printing, and customer management. Mr. Joe Anthony, the mic is yours.
Thank you, Mr. Augustine. Am I audible?
Yes, you are. Yes, you are. You can proceed.
Yeah, thank you. So once again, thank you everyone for joining this session. So here I'm going to present on Janoshka and what we do and what is our nature of business and where we located it. So Janoshka is a pre-press for packaging is our passion. Who we are. Janoshka located in Germany, in Kippenham. This is our headquarters. So as you can see from the left, the third person is Manfred Janoschka, who's the founder of Janoschka, which founded in 1976. We are the global partner of stuff over 1,600 globally. We have 21 sites in 12 countries. The complete value chain that we cover in Janoschka is from the design adaptation until preparing the cylinders and delivered to printers. So we produce in the early about rotogravure 170K pieces with the embossing roller of 2000 with a base of 30,000 together with the flexo plates of 50,000 meter square. With the excellence of 50 years over in the industry experience with the innovations, we widely produce embossing rollers, rotary embossing microblinds, and also customized structure designs. It's also for food and non-food applications, especially when it comes to food industries like Maggi cups and butter cups. All these things has a relief printing, which we can produce the embossing rollers for them. For the surface finishing, we have a prismatic varnish coating, which have a dynamic interactive 2D impression, and also having an anti-counterfeiting feature. For the brand protection, we have a Digimark watermarks, which can be scanned, and to know the brand authenticity also using these softwares. So here I'm going to talk about the Asia Pacific structures. Janoschka, Malaysia, located in Nilai, is our headquarters for Asia. We also have a branches in Vietnam and also in Philippines. Our organization chart, we are reporting to Mr. Uday Kumar, the Managing Director, Plant Manager Gonzalo, and the Willie Low, who's our Sales Director. Our business growth in manpower for 2024, we are about 150 staffs with a revenue of 52.9 million Malaysian ringgits. So the coming slides will will explain on the engraving technologies in rotogravures. The first technology that we are going to talk about is electromechanical engraving. So when we talk about electromechanical engraving, it's a conventional type of engraving using diamond stylus, which will have a variable in size and depth. So that's the engraving machine, electromechanical one, which copper plated cylinder loaded on the machine. By using engraving head, it will be engraving on the cylinder on the copper surface. So the engraving speed 8,000 cells per second using this diamond stylus. As you can see, the variable depth can define the volume of the inks that it's going to carry. The 5% of the tone looks smaller in cell size, whereas in 50% of the cell is in moderate size, whereas in 100% will have a complete full volume in this cell depth. So each and every diamond stylus and its angle has its own depths, which we can define by 120, 130, and 140. Most commonly used 120 stylus for all the packaging in non-food and food industries. For the cell geometry, as you can see, the cells that this ink is going to be filling, and the cell wall, the Dr. blade going to hold it and to remove the excess inks from cells, and the channel will help to flow the inks smoother to print. So as you can see, the 150 and 5% of the cells dimensions that looks like this, whereas we have special tools to measure that and ensure that these cells are produced repeatedly in the specific measurements and the parameters. There are certain lines, screens that we follow based on this defines and fine screen requirements The 70 screen is mostly commonly used, whereas 80 and 100 lines are very fine screen, especially for the fine text. Conventional engraving also comes with additional plugin called Extreme Engraving Head, which can reproduce a very fine text elements. Aside from this, we also have a high quality hinting, which can boost up a positive and negative text from the minimum to the max. Adding to this, we have volume oriented engraving, which ensures that the volume and the cells dimensions follows throughout the cylinders to ensure that perfect process control and to reduce the waste during the printing and color matching. The next technology we're talking about direct laser engraving. So this technology brings us variable in shape, size, and depth. As you can see, the human hair of 100 micron, whereas our DLS master screen can engrave 35 microns with a laser direct of 10 microns. With the exposition of ThinkLab, can do until 2 microns also. So eventually the laser exposed on the zinc surface or copper surface, which engraves 70,000 cells per second, which will have a various shapes, depth, and size. So there are various screens available by master screens and also single shot. So this helps us to have a print sharp outlines are possible with offset quality with the gravure densities and with the complex vignettes, well closed ink films, and also have a variable cell geometry, variable depth, and extra large cell volumes. It's possible with the direct laser technology. The last technology that we talk about is the laser etching. It's variable only in size. This laser etching technology has a special screens, outline, and high resolution, and especially for the secure printing, text, logos, and sharpness, manual cut and hand screen, it's still possible. So ideally, this is for tipping papers and maximum 1 or 2 colors, especially for line works and fine logos and text for secure printing purposes. So the laser etching have its coat on top of the copper. The laser gets exposed on top of the coating. So that's how the coating looks like. Then the chemical agents removes the exposed and penetrate to the copper. And to remove the etching resist. So that's how the cells looks like at the end. So the final product of laser etching after the chemicals done. So the copper surface, all these 3 technologies requires to have chrome finishing. So this chrome finishing layers up to 7 to 8 microns, but in industry, we also do to 12 to 14 microns as well. So this is to protect cell engraving, also to resistant on the doctor blade and the ink substrates. Dechrome, rechrome is still possible if you run certain meters, then if you want to do, if the cell is in good conditions, we can do dechrome, rechrome. Surface roughness varies depending on the substrate used. To summarize them, so the choice of engraving technology depends on how complex the image or how complex the artwork is. So this defines from the artworks we analyze. If there is a fine text involved in the artworks, we ensure that we allocate the technology to laser etching. If there are fine tones, fine vignettes involved, okay, we allocate to the direct laser or conventional engraving. It's also possible with the surface roughness for customized roughness for various substrates available in the industry. And there are web compensation possible to apply during our cylinder progression itself. We do the final quality control, ensure that the cylinder engraving and the surface parameters and all the relevant information that meets customers' requirements. So this is all about Janushka and what we do in various technologies. And if you have any questions, please feel free to ask me. Thank you.
Augustine?
Okay, now we see that there is questions from the floor.
Mr. Augustine, can you put on your video, please?
All right, I received a question from the floor. First question is, what are the advantages and disadvantages of these methods if compared with flexo printing?
Okay. For flexo printing and gravure printing, there are some advantages and disadvantages in between each of them. When it comes to consistency, gravure printing gives a much better consistency in terms of colors, and in terms of mileage, gravure plays a main role. In terms of mileage, we can print millions of copies, and we can recycle and we can reuse the cylinders. I hope I answer your question.
All right. Another question from the floor is, what is shelf life comparison among the three types of cylinders?
Okay. In terms of shelf life, all three should play. There is no difference in between each of them, as long as how we handle the cylinders and what kind of inks that we apply onto the cylinder, and what kind of blades and what kind of pressure that we applied up the cylinder. All these things are plays around when we're talking about the shelf life. But Janushka offers 6 to 1 years of lifetime, or 200 to 300,000 meters of running meters.
Okay, I would like to add a question here, that is whether the printing ink today supplied in Malaysian market by those printing ink manufacturer, is it suitable or compatible with your technology?
Yes. We use a various ink manufacturer in Malaysia, like DIC, Sigberg, Toyo, Toyacam. Most of the inks that is suitable for gravure, yes, we can use them.
All right. Let me see. There's no more question from the floor. I would like to add one more question. That is, how do you conduct quality control for your roller, for your laser cut roller and your electromechanical engraving rollers?
Okay. For every individual technology has its own QC tools and to check. Yeah. So for example, if you talk about electromechanical engraving, as I was showing the gel cell geometry of 100%, 50%, and then the 5%. So we have a target values that we needs to be followed. And all these three technologies has the own target that we needs to follow. Say, for example, in 5 microns, or sorry, if it is in 5%, if the cell size should be 10 to 15 microns, we ensure that it falls within the tolerance plus or minus 2 microns. And we have a certain tools that we can zoom in the cells by 10, 15, and 30x, and that can clearly give us the results that the cells are produced in a good way, that it is meeting our customer needs and the market standards.
Okay, if I'm a converter, after a long run, maybe sometime I will see the ink optical density changes on my substrate. So if the optical density changes, can I expect that the surface of the roller already worn off?
This can be happen in many cases. Like, say, for example, if the inks are already clogged and stuck inside the cells, it is sometimes the density may go very low. But in these cases, a manual cleaning is still possible. But if the inks is too deep and if it is already stuck, we advise to send back the cylinder and we inspect them. If the cells are still in good condition, we just remove the chrome layer and we just rechrome it back. Because having it manual clean, it's not possible if the cell is the inks are too deep and stuck inside the cells. Yeah. So we just remove the chrome, all chrome layers, and we rechrome it back. If the cells are in good conditions, if the cylinders are damaged and it's cannot use anymore, what we do, we remove the chrome layer and we trim off the copper and we recopper again and we re-engrave again. It's still possible in engraving industry. Yeah.
All right. Here I received one more question from the floor. That is, if we apply thicker chrome, will it give more mileage to the printing?
Actually, that's also another concerns. Actually, the chrome hardness defines the mileage, not the chrome thickness. Yeah. So Janushka recommends 7 to 8 microns, has a longer mileage, but there are some industries, like I work with Philippines and work in Malaysia. So when it's come the inks that we use, if like say for example, if metallic inks and the inks are too abrasive, yeah, and then the doctor blade, like I said, if the pigments stuck inside the doctor blade and we keep running, it's easily can damage no matter what thickness of chromes that we use. So it's how we handle and what kind of inks that we apply onto the cylinder and how we handle after printing. We properly clean and we ensure that we properly packed, and then we can definitely can increase the mileage and increase the lifetime of the cylinders.
Okay. One more question from the floor. How many times can a layer engraved cylinder be redo?
For redoing of cylinders, it depends on the thickness of the plates that we use. Currently in market, there are two kinds of plates, which is welded plates. Usually comes as 3.5 to 6 mm of thickness. Yeah, it's wrap around and then welding happens at the middle of cylinder to make it seamless pipe. There are another product which is available is a seamless pipe, which is produced pipe itself. Eventually that comes like 10 to 12 mm of thickness or 14 mm of thickness. So how much the thickness is, we can longer the re-engrave, like 4 to 5 mm of thickness, we can do redo of 2 to 3 times. Or if it is more than that, we can do for 6 to 7 times. But we time to time check the steel base thickness. We ensure that, yeah, this is good to have a redo or not, we need to produce a new base.
So I can summarize that from what you have just explained, the maintenance of the doctor blade, the selection of the printing ink is vital. It's critical to the quality of the print. Can I say that?
Yeah.
All right. Okay. There's no more question from the floor, and I would like to thank you, Mr. Joe Anthony, for your presentation this afternoon. Yeah. Thank you very much.
Thank you so much. Thank you, everyone.
Our next speaker is Mr. Witawat Wongsorat, and he is the Technical Field Service Manager in the Additive Polymer Solution for Clarion. He has over 14 years of experience across polyolefins, engineering plastics, rubber compound, thermoset, bioplastics, and polymer additive products in different functions, from R&D to technical marketing and business development. He focuses on providing effective technical support to drive sustainable business growth through technical solutions. Witawat holds a master's degree in polymer engineering and a mini MPA in the new business creation and feasibility analysis. Mr. Witawat, the mic is yours.
Thank you for introduction. As you know, my name is Witawat Wongsorat from Clarion. You're welcome to call me Benz, like Mercedes. I'm happy to share some insight on our PFAS-free and siloxane-free polymer processing aid products. The name is AdWork PPA 101FG. Before we start the detailed insight, I would like to brief you a bit about the shark skin and the conventional PFAS mechanism when we have the blown film process. When we use the metallocene LLDPE resin in the blown film application, we might find the shark skin or manufacture defects during the process. The reason is because of the difference in terms of the velocity profile at the center of the polymer melt. and the edge when it comes through the die. You can see here from the left-hand side photo, when polymer melt pass through the die, they have the velocity profile different between the center and the edge. Because of the edge, the surface friction of the metal part also play the role that make the difference in terms of the velocity profile. So when the velocity profile is too much or too different, when it come out through the die, it also generate the stage. And when its state is too high, it also generate the shark skin. So we have several years that we know that uh, polymer processing it like PFAS or siloxane also can do the job to prevent or protect from the shark skin behavior. In bromine process, if you add PFAS masterbatch or PFAS substance, it will make the thin layer coated on the metal surface and reduce the friction. So when the polymer melt come into contact with the surface, it will not generate too much difference between the velocity profile at the center and at the edge. So when it come out through the die, the film will get smooth. No, not that much state that accumulate in the surface and make the rough surface. However, we also know that PFAS substance also can have a chance to contaminate to the food, to the film. And if the film have to contact with the food, it also can have the possibility to migrate to the food. And if we consume the food, it also have the list of the contamination of PFAS in our body. So more and more regulatory sites, they push more restriction to use PFAS in the food contact packaging. You can see here, I summarize some key regulatory sites. In December last year, European Chemical Agency, they announced that they are under the review to restrict to use PFAS in the food contact packaging. In US, they already announced for 13 states that they ban PFAS to use in the food contact packaging. And November last year, they announced that there are 15 states that going to consider to ban PFAS soon. From the European side, like the regulation of the packaging and packaging waste, you can see here they already announced that they will start to limit the PFAS that allow to use in that allow to detect in food contact film only 50 ppm, and it will start August next year. So from the regulatory point of view, there are more and more concern to use PFAS in the food contact packaging. And moreover, we also know that 3M, the production pan of the PFAS in the market, they already announced that end of this year, they will exit the market. The reason is because of they found the PFAS contamination in the blood of the people living nearby the factory. So more and more concern on the human health and also environmental as well, because of if we can imagine if the PFAS contaminate to the liver, the water take by the animal, we eat the animal meat also can have the contamination. And if we growing the vegetable by using the water that have the contaminate with PFAS, it also can have the tendency of the PFAS that consumed by the human. So more and more restriction is concerned to use PFAS in the food contact packaging. However, we have some technology already in the market to came as the PFAS free. So I list down here all of the technology that have in the market for the PFAS free solution. You can see here the first technology is the liquid phosphide. For liquid phosphide, it can use for the LLDPE application, but not for the PP. The food contact from USFDA limit to use below 2000 ppm in LLDPE resin. For number 2 and number 3 is the silicon substance. You may know already that polydimethylsiloxanes of modified silicone also can do the job because of the functional or mechanism of this product, also similar to PFAS, is the create the thin layer to coat the metal surface. However, we also found that the drawback to use those kind of the substance also can have the negative impact in terms of the printing ability or lamination, or if the customer have the metallization process. This kind of the substance can generate the low molecular weight part migrate to the surface and affect to the dye retention, and sometimes affect to the delamination of the film. The fourth one is PEG, polyethylene glycol. Normally, we know that polyethylene glycol also can do the job. Some PFAS manufacturer, they also combine PEG together with PFAS to have better effect in terms of the shark skin removal. However, to use only PEG alone, the thermal stability of the product is not that good. So sometimes the customer will find the change of the color. Even the master batch form also change the color. The next one is the solution from Korean. The name is At Work PPA. We claim that it is 100% organic substance, no PFAS, no siloxane, no silicone, and no inorganic substance. The maximum limited by US FDA is 5,000 ppm in polyolefin application. So it means that both PE and PP also can apply our products inside. The last one is the inorganic substance like boron nitrile. For boron nitrile, the user have to select the right particle size, because of if they get the wrong particle size also have tendency to have the agglomeration, and this agglomeration also can make the film surface is not smooth. Yeah. So from the challenge that we have, we take the challenge from the regulatory point of view to develop the product which is safe for the human and environmental. For the processor or converter side, we also take the challenge from the line production efficiency have to keep the same, no any drop of the efficiency. For the end customer, they should get the quality, the same quality of the film performance compared to the PFAS polymer processing it. Okay. The product itself, the apparent look like this. FG stand for fine grain. You can see here, we already try to produce 10 up to 30% of the master batch. You can see here, the reference apparent look like this. We have no any issue in terms of the process when we prepare up to 30% active content. And the thermal stability of the product is quite good. So you can see here at 280 degrees Celsius, the weight loss just only less than 0.5. And at 320 degrees Celsius, the weight loss about 0.9. So in terms of the processing window, we can apply in terms of the blown film application and also cat film application. The recommended dosage to use in the length of 1,000 up to 5,000 ppm, depend on the polymer type and the process, and also the target of the use of the customer. For the normal blow film application, we recommend 1,000 up to 3,000 ppm. But if the customer focus on the dye build up, to have the good dye build up performance, we recommend to start by 30,000 by 0.3 up to 0.5% of the products. You can see here, we keep the keywording here, PFAS free, silicone, siloxane, inorganic substance free. The product itself did not label as the hazardous material. We have the food contact approval from US, from Europe, Mercury from China, GB, and Japan positive list. We also send the product to check the silicon content and fluorine content, and from the third-party lab, and we found no detect. In terms of the performance, you might know that critical shellac is one of the factor that you can consider as the resistance of the shark skin. So if the critical shellac increase, it means that the chance to have the shark skin is lower. You can see from the bar graph, when we did not add any polymer processing aid, the critical shellac is about 260. When we introduce conventional PFAS in the market, this one we use 500 ppm of the PFAS. The critical shellac going up to 618. And we also can achieve the similar level of the critical shellac when adding 2000 ppm of our products. However, the method to check the critical shellac, when the method is different, the critical shellac also different. We also found that some customers use capillary rheometer, some customers use the real critical shellac at wall when they do the real process of the extrusion. So we recommend the customer to check the surface smoothness as well, because of sometimes if the customer usually capillary rheometer, sometimes they will find that the critical shellac is not in the same length of the PFAS. But at the real process, we can find the surface smoothness is there. You can see here at the beginning, before we adding our products, and when the time pass to 10 minutes and 30 minutes, we can get the smoother surface. In terms of the blown film application, we also check the time to remove shark skin. You can see here for the gray line, we did not add any polymer processing yet, so we will always find the shark skin. After we add standard PFAS PPA in the market 1 and 2, we also found that they have the reduction in terms of the shark skin. We found that for standard PPA1, the time to remove shark skin to almost 0% is about 30 minutes, and 40 minutes for the PFAS PPA2. We found that at 0.3% or 3000 ppm of our products can provide a similar trend of the time to remove shark skin as the standard PFAS PPA1. In the real process of the customer, we also have the reference photo here. You can see that we produce 100 micron with the 3-layer film structure. The composition inside vary the dosage of the metallocene LLDPE. You can see here at 0.2% or 2000 ppm of the products. In the beginning, the bubble transparency is not good. After we add for 5 minutes, 15 minutes, and 30 minutes, the bubble is clearer, and the transparency is look good at 30 minutes. Okay. We also do the zoom in into the surface of the film by microscopy. You can see that at the 30 minutes after we add the polymer processing aid, both PFAS type and our products, at the end 30 minutes, we also can find a similar level of the surface smoothness compared to standard PFAS PPA1. But for PPA2, in the previous slide, you can see that the time to remove shark skin is almost 40 minutes. So at 30 minutes, still have some roughness of the surface. In terms of the dye build-up, you can see here we conduct the dye build-up using the metallocene LLDPE resin. After we run 1 hour until 6 hours, the dye build-up is there. You can see the black color substance at the dye. After we compare with the standard PFAS, 500 ppm, you can see the improvement in terms of the dye build-up. like I mentioned in the beginning, if you would like to get the same performance of the 500 ppm drop, the PFAS PPA, you have to start by 3000 ppm of our products. You can see here the performance is look similar. But if you would like to get better performance compared to the PFAS, you can add 5000 ppm and you will get the better performance. You can notice that we use more dosage compared to the PFAS. But when you calculate the cost per use, the cost per use will be similar or same compared to the PFAS solution. Here we do some comparison of the thermal stability of the PFAS-free and PFAS in the market. You can see here our product is the red color line. The decomposition of the product start by about 280 or 290, and then it will start to decompose. For the first two lines, NBA1 and NBA2, is the siloxane and the modified silicone in the market. You can see here at the processing window of the cat film or the blown film application and or the cat film application already have some degradation of the product itself. So that's why sometimes if the product used in the product, if the PPA, this type of the PPA used in the film that have to laminate or print also have some issue because of a lot of the degradation of the product itself. The NBA3 and NBA4 is the PFAS-free and silicone-free PPA in the market. You also can see that the thermal stability is lower compared to our products. The reference PFAS in the markets, PFAS, PPA1 and 2 is the green line. Yeah. In terms of the performance in the film application, in the real film application, you can see here we check the heads of the film with no any PPA. The film have the shark skin, so the hash value is higher. But after adding the PFAS and PFAS PPA and adding our products, also can lower the hash. So it means that the shark skin already removed. We can maintain the transparency, and you can see here not that much gap in terms of the transparency. This one we generate the film from the laboratory scale machine. In terms of the color, like LAB color of the film, we can keep the same, no any negative impact on the LAB value. In terms of the product that have to do the printing or lamination in the next step, we also do the study on the dye retention performance. You can see here with no any polymer processing aid, we found that after the corona treatment, we can achieve 44 level of the dye, and then it will drop by the time, and then keep at 40 level until 1 month. With at work PPA, the red color line, we start to get the dye level at 42, and then drop to 40, and maintain until 1 month. With the standard PFAS in the market, it starts at 42, then it will drop to 40, drop again to 38, and keep 38 until 1 month. But for the lower two line, it is the siloxane PPA and the modified silicone PPA. You can see here in the beginning, they also can achieve 42 dye level. But after that, it will drop significantly to 36 and keep 36 until 1 month. Another modified silicone substance here, after adding, you can see at 38 can achieve the dye level and lower to 34 until 1 month. And we also have no any negative impact in terms of the kinetic COF for film to metal. In terms of the
Mr. Vitawat, can you
Yeah.
please wrap up in 4 minutes? 4 minutes.
Okay,
Please wrap up.
almost done. Okay, in terms of the mechanical property, we already test and we found that no any negative impact in terms of the mechanical properties like tensile properties and elongation. For the seal strength, we also conduct the heat sealability at 110 degrees Celsius. We found that no any difference between our product and the conventional PFAS, but we found lower value seal strength when using the siloxane and modified silicone PPA. In terms of the regulation, like I mentioned, we already have full support of the food contact regulation for Europe, US, Mercosur, China GB, and Japan positive list. Okay, so all of the challenge here we already solve. If you interest in our products, you can contact our team here. Mr. T is the account manager for Caribbean, Singapore, and Malaysia. And we have Miss Joanne, our distributor from Caribtech for Malaysia market. Okay. Any question?
Thank you, Mr. Vitawat. I have two questions here from the floor. First question is, could you elaborate more? Why lower dosage of Edward PPA 101 FG would cause dye buildup?
Yeah. Actually, because of our product need, the mechanism of our products did not provide the thin film coating or the thin layer coating on the surface. It provide flow improvement to the polymer melt. So if the flow improvement is not enough, so we will found the dye deposit. So that's why when we conduct the dye build-up test at lower dosage of the Edward PPA, I mean lower than 3000 ppm, we did not find a good performance. Yeah.
I see. Okay. The next question is there any study demonstrating heat resistance of PPA 101 FG at various temperature?
Heat resistance of...
Yeah, at various temperature. You did at 280 and 320, I think. Am I right?
Actually, I will share my screen again. Okay, the thermal stability here, we run the TGA. So the TGA will start at the low temperature up to the high temperature. So from here, you can see that at lower temperature than 290, we lost less than 0.5% of the products. So it means that the thermal stability at below 290 degrees Celsius is quite good. Yeah. And if we increase, normally we consider 10% weight loss is the critical to consider is not a good product. So you can see here at 400 degrees Celsius, we start to have 10% weight loss of the products. Yeah.
Oh, okay. So okay.
Yeah.
All right. We have time constraint, and we thank you very much, Mr. Vitawat, and we thanks all the participants. Yeah.
Thank you.
Okay. Now, our third speaker is Mr. Kaku Kohli, the CEO of Kohli India and a board member of the Global Rotogravure Association. Mr. Kaku Kohli, the mic is yours.
Thanks, Augustine. Am I audible?
Yes, you are. Yes, you are.
Okay. Thanks. Yeah. Good afternoon to everyone. It's truly wonderful to be here with you all. And I want to begin by thanking the Malaysian Plastics Manufacturers Association for inviting me today. I genuinely appreciate the opportunity to share some thoughts and practical experiences with this group. My name is Kaku Kohli. I'm the Managing Director of Kohli. a company that has spent more than 5 decades working in the gravure printing, coating, and lamination technology. Over the past few years, we've been closely involved with converters across the world who are making the shift towards recyclable and monomaterial packaging structures. And what's encouraging is that this shift is no longer just a future discussion. It's something happening in real time on shop floors everywhere. That's why today's topic, high performance lamination and coating for recyclable packaging structures, feels so relevant. The challenge for many converters is not just about meeting sustainability goals. It's about doing it while maintaining high bond strengths, barrier performance, efficiency, and overall cost competitiveness. So the real question becomes, how do we bring sustainability and performance together in a way that works for day-to-day production? My aim in this session is to keep things very practical and relatable. I'll share learnings from real installation, common challenges we see, the structures that are running well today, and how advancements in coating and lamination technologies can make this transition smoother and more predictable. It's nothing theoretical, just honest, experience-driven insights from the field. So once again, thank you to MPMA for hosting this session, and thank you all of you for taking the time to be here. With that, let me share my screen and we will get started. High performance lamination and coating for recyclable packaging structures. The presentation includes sustainable packaging trends, that's recyclable packaging, the challenges faced by converters today, the enablers to make this change, namely materials such as paper, monomaterials, water-based coatings, solvent-less adhesives, and lacquers, and the equipment allowing you to make such kind of recyclable substrates. Then we will look into a couple of case studies, and then Kohli's sustainability solutions. And then at the end, there will be a short summary and key takeaways. Sustainable packaging trends. Shift towards monomaterial and recyclable laminates. This is what every converter is trying to make the shift all over the world, because many brand owners have kept goals of having 100% recyclable, flexible packaging by 2030. There are water-based and solventless systems which are gaining ground due to sustainable packaging trends, and the equipment flexibility is driving sustainable development. The packaging paradigm shift, the drive towards a circular economy. I'm not sure about Malaysia, but everywhere I've seen in Europe, there is a legislative pressure from the government for global bans on single-use plastics, and of course, the extended producer responsibility. I will ask you all later about this pressure, whether you have from the Malaysian government. And then, of course, you see the new generation, they are growing their preferences towards sustainable and more recyclable brands. Then brand owners and corporates are pledging towards using 100% reusable, recyclable, or compostable packaging. And the result is an urgent need for high-performance, recyclable, flexible packaging. The core technical challenge, or let's call it the impossible trinity, can it also be sustainable without losing performance? So as you see the three circles, the one on the left, recyclability is basically nothing but using monomaterial structures which are recyclable. But such monomaterial structures have to have proper barrier performance against oxygen, moisture, grease, and many more. And at the same time, they have to be cost efficient for their high speed production. So the traditional solution is very easy. It's a multi-material laminate, which is difficult to recycle. And the new approach is to use the advanced coating and lamination technologies to make the structures easy to recycle. The core economical challenge for the impossible trinity. Well, first of all, it's the building productivity and values for such sustainable material. At the same time, you have to be sure that you're lowering the energy and carbon emission. And most important of all, to everyone, the converter, the brand owner, the purchaser, is how to lower the operating cost. Let's look at some challenges in the recyclable structure. So the traditional structures is normally polyester with polyethylene, that is PET with PE, or a polyester aluminum foil polyethylene structure. But now everyone is trying to replace it with a PE-PE structure or a PP-PP structure. But then they have to be careful because it has to maintain all the barrier qualities, the sealability properties, optics, and machinability. So we have to adapt to the new adhesives and coatings available in the market today. And the most important thing, again, is to lower the carbon footprint during conversion. So as you can see on the right corner down, such recyclable materials or sustainable materials have to have the oxygen barrier, fragrance barrier, heat resistance, productivity, and recyclability. The monomaterial opportunity. So the goal is very simple and which everybody knows. It's to produce a single polymer family structure. It could be either of PP or it could be of PE. And Kohli's role comes here where we can offer you the solvent-less application for producing a PP-PP structure or a PE-PE structure. Or we can also offer you a specialized, customized water-based coating machine for functionality barrier coatings. The result, of course, of the monomaterial is it's easy for sorting and for recycling. As we all know, the functions of lamination and coating is to increase the mechanical strength and barrier property of a pouch. At the same time, we have to make sure that its sealability properties and the product protection property is very good. And at the same time, it has to stand out in the shelf in a supermarket. So the aesthetic enhancement and print finishing is the most important criteria. Transition to sustainable substrates. So we are shifting from composites to monomaterials, where we can see today that the paper and fiber-based packaging is reviving in a big way. We are looking at the solvent-less applications or the water-based systems, which are replacing the traditional solvent applications and solvent methods. Water-based barrier coatings. Basically, we are trying to get some barrier properties and find an alternative to metallization. Because even after this water-based barrier coating, the film has to have a proper barrier against oxygen, moisture, and it has to be grease resistant. So you see the reel on the right. This is a reel of paper, and inside we have done a water-based coating. This was done by using the Gravier or a semi-flexo coating application. So examples of water-based barrier coatings is what you see here is a paper with a barrier coated reel. But we can also do barrier coatings on PE or PP structures. Water-based cold and heat seal coatings are gaining ground for the snack food industry, for confectionery, for bakery wrappers. The advantage is that the cold or a heat seal lacquer here also is water-based, so it's easily recyclable. And if it's a paper-based pouch, it's repulpable. Anyway, water-based cold or heat seal is compatible with PE or BOPP film also. Cast and cure technology is gaining ground in India because it's enhancing the brand appeal of a product of a pouch without any metallization or any metal ink. What you see on the left here is basically paper which is printed. This, what I'm showing you, is a tea pouch. So it is printed. And the one on the right, you see wherever there was a print, there is a metal effect. Now, this is basically done by a UV lacquer and a transfer of holographic film without using any kind of metallized film or metal ink. As we all know, metallized film is difficult to recycle. So basically, cast and cure technology is used for decorative and functional surface finish, and of course to increase the value of a product and stand out in shelves. Compatibility with green chemistry. So we are looking at water-based coatings. We are looking at solvent-free adhesives and lacquers, LED UV lacquers, and bio-based waxes and hot melts, which basically, if you see down here, all the burgers, they are wrapped in a piece of paper. These are wax coated, food grade. So let's look at the equipment which can enable such kind of sustainable and recyclable laminate structures. So you're looking at a multi-process modular machine, which is, sorry, anybody was saying something? Okay.
Oh, okay, GF. Okay,
Yeah. Compatibility with eco-friendly materials. And what we have to be very, very careful is that because the runs are becoming shorter, such equipment have to have quick changeovers, and at the same time, it should support sustainability. As you shift to water-based from solvent-based, we're talking of higher temperatures and longer drying tunnel lengths. So the equipment should be designed for energy saving, for reducing the power load. These are some of the coating applications that can be used for such water-based or a solvent-free or a solvent-less lacquer adhesive coating. So you are looking at a gravure coating, offset reverse gravure coating, multi-roll transfer coating, semi-flexo coating, flexo coating, and kiss coating. As we spoke about a multi-process modular machine over here, such a machine can have all these coating processes built into one. What Kohli provides as a lamination and coating machines is over here. We provide solvent or water-based dry laminator, water-based wet laminator, which is used for paper and aluminum foil lamination, then solvent-less laminator. And we also produce a combi laminator, or we call it a multi-process laminator, where you can combine the dry lamination, wet lamination, solventless lamination into one machine. So you can choose depending on your structure that you have to make. And in the same machine, you can also apply water-based cold seal. Then we offer extrusion coating and lamination machines, triplex lamination if somebody wants to have 3 substrates laminated together in one pass, wax and hot melt systems, and the multi-process coating and lamination machine. As we all have been seeing, that digital printing is gaining ground worldwide. So we need to have a kind of a sustainable coating and a laminating machine to take care of the digitally printed films. Kohli offers a mid-web combi or a solventless laminator for such digitally printed film. And we also offer a single station gravure printer actually to print white, because the most expensive ink in digital printing is white. So as I said earlier, that you are trying to be sustainable, at the same time, you have to make sure that the cost of production is the lowest. So let's take a look at a typical laminator machine, a solventless laminator, where we have the unwinder, corona treating, coating assembly, then we have the lamination nib, the secondary unwinder, the second corona treatment, and the rewinder. So the advantages are there is 0 VOC emissions. It's ideal for PE laminate or a PP laminate structure. Such machines can offer a very low adhesive coat weight and very low energy consumption. Extrusion and solventless hybrid lamination. In India, the snack food industry is moving towards a 4-layer structure. So the first 3 layers are laminated using an extrusion laminator, and the sealant area is using a solventless laminator. This is very big in India, especially for chips from Lay's, from PepsiCo. And so basically it combines the extrusion coating and solventless lamination application. It enables you to produce a multi-layer recyclable film, and it enhances the bond strength without any secondary curing time. So your productivity can increase because there is no curing required if you are using an extrusion laminator. Let's look at a triplex laminator. So what you see here on this is basically a solvent-based laminator, and this is a solvent-less laminator. So you're looking at a triplex where we are combining two hybrid technologies, one being solvent-based, that is for the first two layers, and the last layer is using a solvent-less lamination because that comes into contact with the food being packed inside. The machine can be slightly changed, and we can make a machine where you can use these two machines separately and independently as required. And it can also be used in tandem to make a laminate of 3 layers in one pass. You can produce barrier film, paper, sealing structures all in one pass. Wax and hot melt lamination, we are looking at compostable and bio-based packaging, renewable waxes with low temperature bonding, and such machines have high speed production with low environmental impact. Wax coating is very, very popular if you look at chewing gum wrappers today being produced in the world, butter wrappers that you see here, cheese wrappers, and as I had shown earlier, the wrappers used by all the burger chains in the world. The most important point to look at such a equipment is how efficient is it when consuming energy. You shift to water from solvent, you're looking at high temperatures, more heat loads, and a longer drying tunnel length. So the equipment has to be innovative and with a very good drying and exhaust design. And it should have a precise and real well-designed air recirculation system, sometimes with LEL control if solvent is involved, where you can reduce your solvent consumption by over 60 to 70%. Safety this cannot be ignored anywhere in the world. The equipment has to be CE conformity, explosion-proof design. Static is a very big challenge today because as the films are getting thinner, production speeds are becoming faster. This is a big challenge in a lot of machines. So the equipment has to be ready for anti-static elimination. And we at Kohli, we believe very strongly that just eliminating static is not enough. Because over the time, 1 year, 1.5 years, the static eliminating bars accumulate dust and the power reduces, which you may not be aware of. So at strategic location in a machine, you should have static measuring sensors. And whenever there's a static bar where the power is reduced, you will get an audible alarm that at that point, the static is high. You can go and clean up the bar and reuse the same bar again. And of course, all equipment should be should be equipped with CO2 fire suppression systems. Precision web handling is very important as films are getting thinner and you're using paper. The machine should be able to operate at high production speeds with very, very low tension control. And as you see here, we have scanners available today in the market, which can be mounted on a coating machine or a laminating machine, which will help you to reduce your coat weights and be sure that you're getting a uniform coating across the web width, across the length of the web in high-speed production. So as you see on the right down here, today's machines can go as low as 8 microns in polyester, PETG used in shrink wrappers, BOPP as low as 12 micron. I think in India, we are reducing further to 10 micron very soon. CPP, BOPA, shrink PVC, MDOPE, polyethylene, paper, and aluminum foil. High productivity is the biggest challenge when we talk of sustainability and producing water-based lacquers and at the same time reducing energy consumption. So we are looking at a high speed even for barrier coatings, which are water-based with low solid content. Quick job changeovers is very important because today the runs are getting shorter and shorter because the SKUs are increasing by all brand owners. Your equipment has to have the lowest waste setup. The equipment should be having the smart HMI and diagnostics, which is very important for predictive maintenance of our equipment. And of course, today you cannot have an equipment which is not compatible with Industry 4.0, IoT, or AI.
Mr.
Right.
Kakakoli, can you
Yes.
please wrap up in 3 minutes?
Sure. I'm finishing in 1 minute.
Okay, very good. Thank you.
On the right, you see is a graph, what we can give you as it can be connected to your ERP system, which can give you the entire production-related data. Case study here, we are trying to substitute polyester polyethylene material with PE material. So basically, we are producing a material which has to be having a similar barrier strength and the similar performance. The advantage was to create an all polyethylene PE structure, which is compatible today with widely available recycling streams in the world. It is maintaining critical barrier properties against moisture, grease, and aromas. It's eliminating the need for the non-cyclable polyester material, and it's easily printable, sealable, and 100% recyclable. The other case study was for producing a PP laminate structure, again eliminating the polyester which was used for stiffness and clarity. So here we use the water-based barrier coating on the BOPP film to enhance its barrier property. And the result was a OPP, water-based coating, solventless adhesive, and a CPP structure. The advantage, again, was all PP structure compatible with a growing PP recycling infrastructure. It preserved the high gloss, high clarity aesthetics desired by brands, and it provided a robust high barrier solution for snack food, confectionery, and more products. Kohli's sustainability roadmap, we are spending a lot of time, effort, and of course money on R&D for better water-based barrier coating applications, which are having energy optimized systems. We are producing modular hybrid platforms, and we are collaborating today with many brand owners and barrier coating lacquer manufacturers. These are the machines that we offer. This is the multi-process laminator that we spoke of. This is the combi laminator we spoke of. A quick look at the Gravier on the right, which is printing machine off this topic, but this is using 100% water-based inks, again, sustainable. So a quick summary and key takeaway, Kohli enables high-performance sustainable substrates and laminates. Efficiency, safety, flexibility, and energy savings is the prime criteria for all Kohli's equipment. And we are producing ready for the future of recyclable packaging. So thanks everyone for tuning in. I hope this session gave you a few useful ideas you can take back to your teams. And thanks again to MPMA for inviting me today. If you have any questions, please feel free to ask and I will be happy to answer. I hope I was within the time.
Thank you, Mr. Kohli. I have a question from the floor. That is, do you have any comparison between the conventional barrier lamination film versus the monostructure PP and PE?
Yes,
do you have any comparison?
Yes, we did. The traditional film was the polyester PE or a polyester aluminum foil PE substrate, depending on what kind of barrier protection you need inside what you're packing. So we shifted the polyester PE to PE and PP. So basically what we did was we applied a water-based lacquer on PE film, and the water-based barrier lacquer provided all the barrier required, which was being given by a polyester film. So we didn't need the polyester film to provide such a barrier. At the same time, we did the same product, same process with a PP film. So we did a barrier. In fact, today we are in fact even trying a special barrier lacquer on a PP film, where even metallized film may not be required for providing such a barrier.
Wonderful. Just a request whether any possibility that you can share these results.
These are actually being done by some brand owners. So these are not mass-produced films yet in the market. They have been approved and the test results are very good. And these are being done by brand owners. So today, maybe I would not be able to share this result, but give me some time and I will take permission from these brand owners and I can share them.
Okay. Thank you very much. I think we have a limited time that we need to record this. So thank you very much. Thank you for your presentation, Mr. Kohli. Yeah, good day. Thank you. Now, our fourth speaker is Mr. Barry Homewood, Head of Sales, Flexible Packaging from CAM. Mr. Barry Homewood is a highly respected figure in the flexible packaging industry with a distinguished career spanning several decades. Mr. Homewood has held a series of senior leadership roles across leading packaging organizations such as Bob's, Atlas Converting, which is now known as CAM, where he has been instrumental in driving business growth, operational excellence, and sustainable innovation. His deep understanding of materials, market trends, and technology has made him a trusted authority and valued contributor to the industry's ongoing evolution. We are privileged to have Mr. Homewood with us today to share his insight and reflections on a career dedicated to excellence in flexible packaging. Mr. Homewood, the mic is yours.
Thank you very much. Let me share my presentation. Good afternoon, ladies and gentlemen, and thank you very much, MPMA, for inviting me to present today.
Mr. Homewood, we can't see your slides, Mr. Homewood.
Okay.
Can you share it again?
Will do.
Something is coming on. Yes, can you put full screen, Mr. Homewood?
Yep.
We can see two screens, Mr. Barry Homewood, we can see two. Okay, now it's one screen. Okay, thank you.
All good? Okay, thank you. Thanks again, MPMA, for inviting me to present today. I really wanted to address the question in slitting rewinding. Often we get asked, should I look at a turret rewind slitter or a duplex rewind slitter? And this is a question about productivity and your product mix. So I'd like to address that. But firstly, I'd like to introduce our business to you. We are headquartered in Germany. The position here, you can see the factory set up in Wiel, Germany. And here you can see where our regional sales are. So you can see more than 50% of our turnover on slitting rewinding machines is in the Asian countries. So this is a very important region for us. Second to that is really shared with the Americas, Europe, and Germany. And then Eastern Europe is the fourth, and the rest of the world is covered in the final position. But Asia is very important for our market. The Kampf Group, we're more than 100 years old. Kampf only manufactures slitter rewinders. We're in many industries in the slitting and rewinding, but only slitting and rewinders. We don't invent printing or lamination, it's only slitters. So more than 100 years experience. Currently in 2024, we had around 800 employees, and we've got around 11 companies worldwide. Often these companies are service companies. We have service operations based in North America, India, China, and of course Europe. Talking about installed base, we've got, we think, more than 10,000 machines already running in the marketplace. And of course, our passion is 100% just for slitting and rewinding. One of the things we're investing in our headquarters in Veal is a new technology center. It's called the Link, and the Link is the word that we'd like to bring our technology and people together. And this is really an area where we will have multiple slitters available to test your material. So we had a lot of discussions about new materials, mono materials, barrier materials. All of these materials have to go through the slitting machine at the end of the process. So this technology center, you can send us materials, we can test new materials, or we can just show you the productivity that we can gain from your materials running on our slitting and rewinding. It's more than 3,000 square meters of floor space, and we will have our latest slitting and rewinding technology installed. The launch date is mid-2026, so I look forward to being able to welcome you to the opening of the Link. Just to cover some of our portfolio of machines, really focusing on flexible packaging. Talking about the areas that we are involved in, we're involved in the big slitting rewinding machines for bi-X machines. So these are for the BOPP and polyester lines, typically 9 meters, 10.4 meters. And now we've just developed the widest in the world at 12.4 meters running BOPP film. This is a new development from Bruckner, and we're the first slitting rewinding manufacturer to be able to offer a solution at that web width. Of course, we have flexible packaging, and that's where I'll show you some more information. Rigids is our paper and board applications. So this would be label stock or paper applications. And then the technical applications is really things like battery separator film, capacitor films, these highly technical films. So these are the 4 areas that we are working in. Looking at the flexible packaging platform, we've got 3 areas with the shafted machines and 1 station machine. What you're looking at here is our Silverline platform. This is a new platform of machines that we just recently launched at the K Show. And really, this is a very modular design machine. So we can have different unwinds. So we can have integrated unwinds into the slitter, or we can have separate unwinds. We can have duplex rewinding, or we can have turret rewinding. So there's many options on this machine. It's very versatile. It's built in modules, so we can pre-configure the machine, and once you finalize the specification, we assemble the machine very quickly, so we can offer very quick deliveries on these machines. Our target is to be able to deliver the machine within 4 months. Here you can see rewind diameters on this machine is 610 millimeters, which is quite common in the flexible packaging market, and web widths 1.4, 1.7 meters wide. So it's really dedicated to the flexible packaging market. Speeds up to 700 meters per minute. The next platform we come to is our Blue Line platform. And really the main difference between this and the Silverline platform is a couple of things. Web widths vary. So in this platform, we go from 1 meter web width up to 2 meters web width. The rewind diameters are bigger. Here we can go up to 850 millimeters, or even 1,000 millimeters on a specialized shafted machine. And also the speeds are up to 800 meters per minute. Levels of automation on this can also be increased. And then the Blackline platform is our fully automatic slitters. So this is where we incorporate our most automation. So these machines can have web widths up to 2.2 meters. We're talking about rewind diameters again up to 850 millimeters. And the speeds on these machines is up to 1,000 meters per minute. Typical applications for these machines are things like snack food production, water bottle labels, this type of area in flexible packaging where you have high volumes and you need a high throughput. And then finally, for flexible packaging, for those converters that need very large rewind diameters or heavy weights, we have our station type slitters. Now, these slitters don't use a rewind shaft, they use individual stations. And we can have widths up to 4 meters, rewind diameters up to 1.2 meters, and speeds are up to about 1,200 meters per minute. So these are really for producing large rolls. Also combining with slitting and rewinding, or when we have high productivity, we need to look at how we're going to handle the rolls after slitting. So we have very different developments from semi-automatic to fully automatic systems, whereby we can take the reels off of the slitter rewinder automatically. We can weigh the roll, we can label the roll inside the core and outside. Then we can wrap it or bag the roll, and then we can automatically palletize it. And we can have different stages in between all of those. So this is really important when we start to talk about high productivity machines. We can combine it with a total turnkey solution for your packaging needs. And of course, with all our machinery, we have to support it for after-sales service. I think we have currently around 85 field service technicians based around the world. So we can service you directly for spare parts. We have a digital solution for our machines, as we talked earlier. So we have high connectivity and production monitoring, all of these things that you would expect from today's machinery. But the main thing is we can support you wherever you are in the world with local engineering. So coming to the question, turret rewinding or duplex rewinding, what's the best for my productivity? I've chosen the Titan Slitter Silverline platform to make the comparisons because, as I said earlier, this is a modular machine. The performance between the turret and the duplex machine is exactly the same. So just to reiterate what the Silverline is offering, 700 meters per minute speed with a fast acceleration. We're talking about a turret cycle time of around 40 seconds. And that's meaning between stopping and restarting the machine. We've spent a lot of time with energy efficiency on these machines. So we have regenerative braking, we have feeding back into the power, real-time energy monitoring on these machines. In Europe, we're seeing more and more requirements for energy monitoring on the machines. So how much is the machine consuming? Because the operators want to understand what the cost is per job. Ease of use, this is something we've developed on the Silverline. We see in slitting and rewinding departments quite a high turnover of staff. And what we've done is we've made a very intuitive guided system for the operator to set the machine. So he can preset the machine using a number of steps. The operator can set up the machine from a new job. And the idea is that we can train people very quickly and we can share the information very quickly on the machine. The Silverline also incorporates some more automation, things like auto web threading, so we can web up the machine very quickly, roll pushers so that the operator doesn't have to lift heavy rolls, automatic knife positioning or digital positioning of the knives. All of these things are benefits for the productivity of the machine. The Silverline is also an all-electric machine. There's no hydraulics. on the machine, so it's a cleaner environment, giving less maintenance. And then really, when you're purchasing from Kampf, you know the quality and the future proofing is there. It's using proven Kampf technology. We give reliability and a longevity of our machines. We're still servicing machines that have been in operation for more than 40 years. So the machines are certainly built strong. And with the Silver Line, as I mentioned, we have the modular design, utilizing the latest technology in edge guiding, automatic knife positioning, the knife holders. All of this is the latest technology. And building as a module, we found that we can really shorten the delivery times of these machines. And I think that's important for our flexible packaging industry. You tend to purchase the press, the laminator, and then we need the slitter. It tends to be the last decision in your process. So we need to be able to deliver quickly. And as I mentioned before, we have a global after-sales service. Our warranty is very strong. We offer the parts. If you need the part fitted, we'll include the labor and, of course, the shipping on warranty parts. And I think that's important, that you're buying into what we offer is a complete package. It's not just a machine. So here you can see what we talk about duplex and turret. Duplex, we're talking about really a machine like this on the top, whereby you've got two shafts. You can see one shaft here and one shaft here. And then on the bottom is a turret rewinder where you have 4 shafts. So you're basically winding on one set of shafts and you're preparing the cores on the second set of shafts. So then when you come to change over, it's an automatic sequence. So that's the difference between a duplex and a turret, 2 shafts or 4 shafts. So what we decided some years ago was that we really needed to develop some software that would give us the capability of giving you a production estimate through our machines. And we worked with the Cambridge University to come up with a software package that we've developed continuously since. And really what we can do with this software now is if you share some production details with us about material types, so the thickness of the material, the rewind lengths, the cores, all this sort of basic information, we can make some very accurate reports on productivity that we would expect from our machine. And then we can also compare it with other models in our portfolio, or we could compare it with your existing machine to see what the increase of productivity may be. So this is just an overview showing basically where you can see some data output. This is a production breakdown, so you can see it's a pie chart showing machine running, set changes, mother roll changes, job changes, and splices. And then here you can see a ramp up of a machine accelerating, reaching the running speed, and then deaccelerating. And then here you can see a job schedule. So this is every set that comes off of the machine, and where you can see a gap is where a mother roll changes. So we can be very precise with this calculation and this production software. So what I did was I took 3 jobs to try and make a comparison. So here we've kept the thickness of the material. You can see in the yellow boxes, I've just said 40 micron across the board. We're looking at job A, which is only 3 slip reels out, job B, which is 15 slip reels out, and job C, which is 30 slip reels out. But everything else is the same. Web width is 1200, unwind core is 6-inch, rewind core is on a 3-inch, and the job size, the rewind lengths that we've calculated with, is the same. So this is 30,000 meters on the job size. Everything is comparable. The only difference is the number of outs and the slip widths. So that's the data that we've used to make these comparisons. So if we look at the first job, here we have the 3 out, and on this side you can see the duplex rewind and then the turret rewind. So here the data coming out for the 3 slits is an average run rate of 14,000 meters per hour, and on the turret machine it's almost 16,000 meters per hour. This is the run time for that job. So remember, we said we're going to run 30,000 linear meters. So this is saying that on the duplex, it will take roughly 2 hours. And then on the turret machine, it's less than 2 hours. The running time of the machine, 50% and 58%. And then this is just a calculation. If you were to run that job for a period of time, say a year, what the net output would be. But here you can see the productivity breakdown in these pie charts. You can see that the machine running time is much less compared to the turret machine. And that's really because we're saving time on the set changes. And that's why we talked about the 4 shafts. You're running on one set of shafts and then you're setting up on the other set of shafts. So that's really where you're making a saving. So even with 3 slit reels out, it's showing an 11% saving or increase in productivity. If we move on, considering the 15 out, same calculation, same material. Here you can see, again, the average rate is 10,000 linear meters. And then on the turret, it's almost 12,500. And obviously the running time is increased here because we're saving more time and the output's more. So with a 15 slit reel, the duplex compared to the turret, we're getting more than 20% increase in productivity for that same job. And again, you can see here with the productivity breakdown, the machine running is much less on the duplex compared to the turret machine. Then if we go to the final comparison, which was the 30 out, here you can see it's a completely different scenario. We're getting a much less materials per hour out because of all the job changes or the set changes. It's taking a lot longer. But again, the difference between the turret rewinding and the duplex rewinding, we're getting more than 25% increase in productivity with a turret machine. And remember, this is the same materials. It's the same rewind lengths. The rewind lengths are around 300 diameter roll. So it's a typical sort of flexible packaging roll. But again, we're getting a much higher increase on the turret machine. And then if we were to compare, if we were to bring all those 3 jobs together, so the job with the 3 out, the job with the 15 out, and the job with the 30 out, and compare that production mix with 3 jobs, we're still getting a 20% overall increase in productivity from the turret application. So really the conclusions are, yes, turret rewinding can give you a higher productivity, higher output. What this is really showing is it depends on your product mix. If you go back to the 3 out, we were only getting 10% increase, whereas with a 15 or 30 out, it was 20 or 25% increase. So if you're doing lots of narrow slit widths, then this becomes interesting to consider a turret rewinding machine. So the overlapping functions of the turret machine is really where we make the saving. If you can imagine a slitter rewinder with 30 reels on it on a duplex machine, the operator has to cut the web, he has to tape down each individual roll, and then he has to remove all those rolls, and then he has to put the cores all back on manually, and then he has to tape the tails onto the core and restart the machine. With the turret application, we stop the machine, we have the cores already prepared on the outside shaft, and then we do an automatic cross cut. The taping is already done on the cores, so then we turret over, We pick up the tails automatically and we start winding, and then we start to unload. So not only are we having overlap in setting the machine up with the empty cores, but also we've already started running the machine while we're unloading the finished rolls. So that overlapping of functions is really where the turret application comes in as a benefit. And of course, as I said, the more slip reels out you have, the higher the productivity will be, the increase in that timing. And really the net output of the turret machine, you can either decide I need less slitter rewinders because I can do more productivity with less machines, less floor space needed, less operators needed, less maintenance. Or if you're expanding rapidly and you want to increase the productivity, then go for a turret machine. So I think let's discuss further about how we can assist you. We work with Corvette Technology. Mr. Tony Yao is available, also based in Malaysia. And of course, myself is available on a global basis to help you consider your productivity increases between a duplex machine and a turret machine. Any questions, please?
Thank you very much, Mr. Barry Humboldt. Yes, I do have a question to seek your clarification. My question is on the rewinding tension control technology for thin film and for stretchable film. What's your development of technology in this area?
Yeah, I mean, it comes down to looking at the total tension control through the machine. So we have different technologies on the unwind. So quite often we'll have a driven unwind. So it's a motor generating, not a braking system. So when we're accelerating, it's driving the roll. And then when we're braking, we have the regenerative braking. So we put power back into the machine and save some energy. So this is a very good application for thin films because you can control the unwind tension very accurately using a dancer roller or even a load cell system. So then we come off of the unwind and we come into what we call a center drive. So we have a center drive on the machine, which is a SRAP based roller system. And that's the pull rollers that's pulling the web through the machine. And then, of course, we go through the knives and onto the rewind shafts. And our rewind shafts are using a differential technology, which is our own manufacture. And what we can also do on the rewind side is to put in a load cell feedback. So the operator can select what rewind tension he wants in the finished roll. And the machine will automatically control all those functions, the unwind tension, the pull roll tension through the machine to give that finished tension requirement. So it's a combination of areas through the machine.
Is there a combination of a gap winding technology in this also?
Yes, for applications where we're using sticky materials or open adhesive materials, we can have a gap winding technology whereby the contact roll is not directly touching the rewind packages, but we have a gap maintained as the roll builds up. So it's not in direct contact.
Okay. So do you see the development of wider web, wider and wider? Will that cause much more difficult in the winding technology?
Yeah, I mean, in flexible packaging, not really. I mean, 2 meters, 2.2 meters for some of the big laminators. Yeah, we're working with those dimensions quite often in North America in those countries. But for the film industry, for the BIAX industry, where we're producing BOPP and polyester, then there is a significant productivity increase by going wider. I mentioned earlier that we're talking about the standard in the industry was sort of 10.4, 10.6 meters wide for many years. And now at the K Show, it was developed that Bruckner have sold the first line at 12.4. And we've been lucky enough to secure that business. So we now build the widest slitter in the world. So yeah, certainly for For the film applications, there is a significant benefit in wider webs. And we're talking about webs speeds of sort of 1,500 meters per minute for those applications. They have to be, you know, producing twice as much as the line output. So it's a serious undertaking.
Very wonderful. One last question for me. What about your air shaft development technology?
Yeah, air shafts we don't tend to use so much in flexible packaging. It's mostly used in paper applications and paperboard applications. And then you're talking about using the torque of the rewind motors to generate the tension in the rewind shafts. In general, for flexible packaging, we standardize on differential winding. Differential winding ensures that you have the same tension across the full width of the shaft. And it doesn't matter if you've got some different ink buildups across the width or some gauge variation across the width. The differential slip will allow you to maintain the same tension across the whole web width. So really for flexible packaging, differential. For paper applications, paper and board, then we would use pneumatic rewind shafts.
Okay, great. Thank you very much. Thank you very much, Mr. Barry Homburg, for your presentation and your sharing.
My pleasure.
Okay.
Thank you.
Good day. Now we come to the final speaker for this afternoon session, which is Mr. Claudio Grineschi. With over 40 years of experience in marketing and sales of industrial machinery, mainly in the plastic packaging value chain, from extrusion to converting and filling in the most important export markets, America, EU, Eastern Europe, Russia, China, and Far East. Since 2013, Mr. Grineschi has been working in Mackie, serving the Far East, Australia, and New Zealand markets. Mr. Grineschi, the mic is yours.
Thank you very much, Augustine. Good afternoon, everybody. As Mr. Augustine said, I'm Claudio Grineschi. I'm the sales manager serving the Asia Pacific area on behalf of Mackie. And today I will talk about, we talk about how we how can a blow film sorry is not the right trust you can see. No, you cannot see. Okay. Can you see it now?
Mr. Grineschi, we can't see the slides, sir.
Is it visible?
No, it's not visible. Can you try?
You can see?
Can't see. Can you reload the slide? Stop share and try again.
Yes, of course.
Stop share and try again.
It's saying, okay, just a second. I will try again. Sorry about that. I'm a boomer.
Okay. It's okay.
So it's always difficult.
Okay, we can see the slides.
Now you can see me?
Yes, can see the
Okay,
slides.
that's good.
Very good.
Great. Thank you very much. So, allora, just a few words regarding Macchi. Macchi is an Italian manufacturer of blown film extrusion lines. We are located close to Milano, in the heart of one of the powerhouses of the European technology. I say so because every time you talk about Italy, you think about fashion, food, sports car, bikes, these kind of things. The real point is that Italy is constantly among the 3 most important suppliers of technology on the world level. And Macchi fits perfectly in this kind of scenario. Macchi, as I said, is an Italian company, born in 1961, and we rank among the 5 most important blow film extrusion lines manufacturers worldwide. And we are the only one focused only on extrusion. We only make blown film extrusion lines. We don't do anything else. So all our efforts and investment in research and development and innovation are directed in the field. We have two factories, 5 kilometers one from the other. The headquarters, which are still in the traditional old location of the company, and a second production site where we carry out the assembly of the extruders and of the RecoTrim, our trim recycling line. Altogether, we are 140. We make more or less 50 extrusion lines per year, plus 60 to 70 RecoTrims. That is to say, our trim recycling unit. We export more than 90% of our production into over 120 countries worldwide. Since 2014, 2015, we have been constantly over the 50 million turnover mark, euro turnover mark. And also this year, 2025, even if it's a weaker year for the industry, we are going to be very close to that, to the 50 million mark. As I said, we are producing only blown film extrusion lines from monolayer for specific application, 3-layer, 5-layer, barrier lines, film for agricultural applications, a range of winders, and the RecoTrim, our trim recycling unit. Allora, nowadays, we feel that one of the most important challenges we are facing is to develop to face the challenge of improving the circularity of the industry, that is to say, the recyclability. So flexible packaging nowadays must be designed for recycling from the beginning. They have to provide material replacement exactly to be able to be recycled more easily, have to be down-gauged to save energy, materials, and reduce the carbon footprint and ensure a waste reduction. Actually, there is a European initiative, the CFLEX, Circular Economy for Flexible Packaging, who have dictated the rules for developing a circular economy in flexible packaging. Those rules are the collection, sorting and recycling, redesigning multi-material flexible packaging to monomaterials, identify a solution to sort and recycle, and develop the end markets for recycled flexible packaging markets. What can a blown film machinery manufacturer do is to try to develop more materials and to try to develop as much as possible a market for recycled flexible packaging material. That is to say, to develop a technology who allows you to reprocess recycled packaging material. Talking about monomaterial, the classical definition is that a packaging film to be identified as monomaterial must have a maximum percentage of different resins not higher than 5%, up to 10% total. This, of course, phases out most co-extruded barrier films, whose use is quickly growing as they are non-recyclable because the barrier layer is usually 6, 8, 10% of the overall structure. What we have done, we have introduced a solution to allow the production and the use of a maximum 5% EVOH layer for medium to high barrier. During K25, we presented our new 7-layer line developed for barrier film in symmetric or asymmetric structure for the production of lamination barrier films using high clarity EVOH with EVOH lower or equal to 5% of the total. At the same time, the line can produce 7-layer polyethylene structures for flexible packaging. So what we were displaying was a line up to 2,300 millimeters net width. Production capacity on the paper, 450 kg for barrier film and 550 for LDP structures, but actually we were running constantly at 600 kg per hour in both cases. And you can see the distribution of the screws and the layer distribution. New redesigned die head with innovative flow distribution. The line, of course, at the show was equipped with all the bells and whistles. So it was including the K-Design Frostline scanner. It was including the new Carat K3.3.2 power flow air ring with integrated wax suction device. The Centrofreeze secondary cooling unit able to decrease the field temperature by up to 15 degrees centigrade to avoid any possible blocking even with low towers. And our new supervising system, HMI, the new IoT, and the troubleshooting, and the artificial intelligence, the AI developed by Mac, which was the result of all those innovations. As you can see here, this is the new screen of the supervisors. Maybe you should be able to see here that we were really running a 1 micron thick layer of EVOH. And we sent the film to Mitsubishi Chemical labs in Germany for film analysis. And this was the result. As you can see, film distribution, thickness distribution of the film on a 25 micron total structure. We were constantly running up to a maximum of 1 micron of EVOH. This was the measurement of the OTR, given the average EVOH thickness. So a line able to guarantee you the oxygen transmission rate that you desire at a very low thickness. And what is important is not so much the 1 micron. 1 micron shows the precision, the legendary quality of the mechanical processing of Mac. All the die heads are designed and produced, manufactured in Macchi on our tooling machines. But what is most important is that we were able constantly to keep the thickness of the EVOH layer as low as a maximum 4% of the overall structure, thus really producing a film which can be considered as monomaterial and therefore fully recyclable. This means that with a line like this, you are able also to offer, in case you have or you can use some machine direction oriented polyethylene, you can really offer to the market a laminated film with monomaterial laminated film with the outer layer MOPE printed inside. So offering the real alternative to today's structures laminated with PET, BOPET or BOPP. This was presented this year, but we have over the last 10, 12 years, we have been developing a range of solutions to be able to produce film which are more environmentally friendly. So in 2022, we presented an evolution of our traditional POD, polyolefin dedicated line, developed for the use of secondary raw materials, that is to say, regenerated or recycled raw material. So all along the K22, we were running constantly 800 kg per hour of film with an overall total percentage of PCR up to 35%. This was achieved by using hydraulic filter changes in order to be able to change the screens without stopping the line. A new designed die head able to process and to homogenize perfectly the PCR, and a screw profile, a range of screw profiles optimized for the processing of PCR resins. But again, this is not, this was just another step. Everything started with a POD concept. The POD concept was targeted to reduce, to allow converters to reduce the quantity of material, the quantity of resin, and therefore the energy necessary to reuse, to allow for the reuse of PCR, and to allow for an easier recyclability of the material. So a POD line, a polyolefin dedicated line, is a 5-layer line designed to run polyethylene, 5-layer polyethylene structures, and to manufacture at high capacity better, thinner, stronger, and cheaper flexible packaging film. So the 5-layer POD system is a development of the 3-layer, and it allows to use specific new resins in well-defined layers in order to achieve the best optical, sealing, and stiffness results. Main benefit is down gauging. Down gauging, what does it mean, down gauging? First of all, more product packed for the same quantity of raw materials, so your overall cost is reduced. You save in additive cost, and you need less energy for transport, less energy for converting, and altogether you have a lower carbon footprint. Talking about sustainability, and the example is based on collation shrink, because this was the first drive for this development. 20% film down gauging means 25% more product packed with the same quantity of resin. But it means also 20% less trucks needed to transport film to plants. It means lower CO2 emissions due to higher pack yield per 1 kilogram of polymer. And once you go on the shrinking machine, you need much lower energy. Thinner film means faster shrink at a lower temperature. Again, talking about sustainability, we all know the comparison between a stand-up pouch and a glass bottle. And I think that this picture explains very clearly the basic difference. What you fill with one truck of pouches, you need up to 26 trucks of bottles. As I said, the original driving force for the development of the POD technology was collation shrink. Collation shrink is a European market which amounts to some 1 million tons per year. And of course, each saving in this market is meaningful. Other hits can be flexible packaging, hits the stand-up pouches. As I said, with our technology, with the 7-layer barrier monomaterial technology, you can have monomaterial laminated pouches Frozen food is also a field of application for the 5-layer POD film. Diaper compression packaging, and this is a study carried out by ExxonMobil, and as you can see, you have a decrease of 20% in the thickness from 50 to 40 micron. Pallet stretch wood, for instance, it allows you to decrease your stretch wood thickness from 100 micron to 80 micron with pardon me, same elongation characteristics and a better holding force. Next step was, this was back to 2019, develop the 5-layer POD concept to 7-layer, combining barrier and non-barrier with very high output rates. So further down gauging possibilities, so less raw material, less energy, and lower carbon footprint, easier recyclability, using also compatibilizers if the case requires, and new film design ready to comply with the coming PCR usage regulations, which are coming on stream in Europe and in the Western countries anyway. This was our key solution at K 2019. So a 7-layer line, 2.6 meter wide, 1000 kg per hour maximum productivity. And then, as a last point, this is a very, very strong point of the Macchi production, our RecoTrim. The RecoTrim is a trim and film scrap pelletizing machine. Fully automatic, no melt, this guarantees no melt index variation after extrusion. Fully only air cooled, no water involved in the cooling of the pellets, because it runs only with the polyethylene scraps and trims. As you can see, it's a very compact machine. Movable, it's mounted on wheels, only air-cooled, patented twin-screw extruder for easier feeding of the trims and of the waste rolls to the extrusion zone. Strand die head with cutting system, integrated pellet cooling. As you see here, you can see a particular of the twin-screw extruder, which allows to pull the trims in the extruder constantly, independently of the feeding speed. Blade cutting on top of the strand die. By adjusting the rotation speed of the blades, the size of the pellet can be adjusted easily. And this is what you get. Very clean, high quality, uniform pellets with no granulometric variation. No variation of the melt index after the extrusion, so that you can reuse the pellets immediately without any contamination and refeed them in the central layer of your extrusion line. It is a very compact machine, as you can see, can be moved anywhere. Altogether, it takes less than 6 meter space. So the footprint is very, very limited. The line is equipped with an heat exchanger in order to provide cooler air to guarantee the maximum productivity to the die and to the system itself. And that's it for the moment. I'm of course available to answer to your questions, and I would like to thank not only you as a participant, but also the Malaysian Association for inviting us to deliver this presentation to you today. Thank you very much. I trust I've not overpassed by 25 minutes limit.
Yep. Thank you very much, Mr. Claudio Vineski. I have a question here from the floor. Yeah, I have a question from the floor.
Yes.
That is, do you see any challenge running tie layer below 5 micron on a 7-layer line?
No, because well, the tie layer is usually is not pure tie material. It's a mixture of tie with polyethylene. So we can achieve a very good adhesion, keeping the tie layer as low as possible. Also because tie is an expensive material, so the focus is always not only on the recyclability of your production, but also on the economicity of your overall production. And by the way, if you are able to run a barrier layer as thin as 4% of the overall structure, it means that you save money in the cost of the barrier resin. Because you use much less.
Okay.
But with the new grades, we carried out the test with EVOH at 27 moles against the usual 32 moles, which are common in the market. 27 moles cost more or less 10% more than the 32. But if you use half of that, you have a substantial saving in the cost of your overall structure.
Okay. Okay, come back to your machine. I'm amazed of your cooling ring technology. Now, the cooling ring technology that you have is basically to enhance the film clarity and to increase your film output.
Yes, of course. As usual, film clarity is a function of the efficient cooling before crystallization, immediately after the extrusion die. And moreover, when we talk about productivity, the name of the game is efficient cooling. So you must have a very good and very efficient air ring. And in this respect, we cooperate with the best names in the market. That is to say, we cooperate with the K-Design, we cooperate with Plus Control, we cooperate also with other suppliers in order to guarantee that we achieve the best possible cooling efficiency. So we can offer two double lip or triple lip design rings in order to increase as much as possible the productivity, depending on the characteristic of the film.
All right. Okay, I have a question on die, your die technology. Yes. Can you share with me your thoughts on your spiral die versus the stack die?
Allora, we have been using spiral dies since, I would say, 20 years. Our spiral dies are particular in a number of senses. First of all, we have feeding of the melt on the same level. So all the channels, they can be 1 or up to 9 layers, are fed on the same level. This allows us to keep the structure of the die very compact. Very compact, which means less material inside the die, a shorter residence time of the material inside the die, and easier maintenance for everybody, and shorter heating times, setup times. So even when you have to change the job, you have less material to purge, to clean from the die. Okay. Then the flow of the material inside the die is specific from MAC. So our die is divided into 2 zones. On the first one, we split binarily the flow of the material in order to equalize as much as possible the flowing speed. as our colleague from Clariant was saying before, the flowing speed is different if you are in the middle of the flow or if you are against the sides of the die because of the friction. By splitting the flow of the material 8 times, we efficiently equalize the flowing speed, and then we distribute through the channel to the spiral channels to the lips of the die. So it's a very specific die design and is very efficient because it's suitable for all kind of resin. And never forget that all dies are designed according to the specific requirement of the customer inside Macchi and are manufactured inside Macchi for further quality assurance.
Mhm. Okay.
I don't know if it's clear. I hope my explanation is clear enough.
Yeah. I just want to see the comparison between the spiral die technology versus the stack die technology.
Hey, then stack die technology, in our experience, one way or the other, you have always some heat transmission between the different layers. The path of the material is longer, and you have more material inside the die,
Okay.
which translates in more wastage upon the job change and the longer time upon startup.
Okay. All right. Good. One more question from the floor. Reco trim is an online process. Does it disrupt the blown film process once there is the edge trim break during the process? When the edge trim breakage,
Yes.
does it disrupt the Reco trim process?
No, not at all. Not at all. I mean, the breakage will happen between the winder and the Reco trim. So your extrusion process will go ahead continuously. And then it will be very easy for the operator to get the trims and refeed them to the Reco trim. Because thanks to this specific twin screw feeding system, you don't need to how can I say, to run the material through the machine. You just put it into the hopper, and then automatically the machine will draw the trim into the Reco trim. No, actually, the Reco trim is, I call it launch and forget, because you don't even need any support for installation and for startup. It's very simple. It always works and is always very, very productive.
Yeah, yes. And actually, I personally run your line, and I know your Reco trim is a super design. It's a fantastic recycling process. It's really good. All right.
Thank you very much.
I don't see any more questions from the floor, and that's it for the day. And thank you, Mr. Claudio Gineski. Thank you very much for your presentation.
Thank you very much.
I hand over to Francis now.
Thanks to everybody.
Thank you, Mr. Agustin Chua, and to all our speakers for the informative session. Ladies and gentlemen, we would like to now do a quick poll to assess the webinar. This to help MPMA understand the areas of improvement for future webinars and events. Kindly participate by giving us your feedback. The poll will take no longer than 3 to 5 minutes. Yes, can you please answer the poll? It's just a few questions. It's just a few questions to answer in it. It will not take longer than 3 to 5 minutes. So we would like to indulge all the participants to quickly take this poll. Can we have more participants to quickly just take the poll, please. This will help us to improve our future webinars. Only 6%, huh? Okay. Okay, we'd like to close the poll. We'd like to thank our attendees for taking the poll. Once again, on behalf of MPMA, we'd like to thank all the speakers for this afternoon session, Mr. Joe Anthony from Janushka, Mr. Witawat Wongsarat from Clarion, Mr. Kaku Kohli from Kohli Printing and Converting Machines, Mr. Barry Homewood from CAMP, and Mr. Claudio Grignacci from Maki. And of course, we'd like to thank sincerely our moderator for this afternoon session, Mr. Augustine Chua. Excellent job, Augustine. And to all our speakers, all your presentations was very informative. Thank you once again for your time and effort. And to all our participants, please note that the next webinar is on Thursday, and the theme is Green Technologies and Recycling Innovations. Okay, with that, we'd like to say thank you and have a nice day. Thank you to everybody. So you can end the session, Krista.